So this is just to show you roughly what the experiment is all about. Okay, so when you go into this Google Classroom, you would see the experiment, okay, and you will submit on this page, okay, experiment submission page by the group leader, right? So from here we have several resources, okay, where you can download the instructions, okay, as well as some of the I would say guides, okay, on how to use Scilab, okay, in order for you to plot the time response graph, right? So you can download here or just refer back to the what the control engineering notes, okay, similar slides over here actually, okay. I just extract the important parts, okay, on the software only, right? So you can download here or just refer back to the notes that you have in the control engineering class last year, right? Yeah, all right. So just download this one, okay, and you would be able to see something like this, right? Okay, so what this experiment is all about, okay, this experiments, the main purpose is to obtain the time constant, okay, for an open loop system, okay, where this open loop system that's being presented over here is the bread toaster, okay. So here is a typical bread toaster, okay, which will start to heat up, okay, when you put your bread again, and then you lower down this toggle arm, okay. So once you lower down, the bread will go down and it will how should I say, tells the filaments to turn on, that's all, okay. So very classical turn on turn off situation, okay. So no feedback being inputted over here, so we call that as an open loop system, right? So what we have over here is that there is no temperature sensors, okay, to form this open loop system, right? So what or how we control this bread toasting would be through the mechanical timer, right? So this mechanical timer is being controlled by this here, the timer switch, okay. So when you lower it, you may set maybe 2 minutes, okay. 2 minutes means 120 seconds, right? Or maybe 1 minute 60 seconds, whatever it is lah, right? So you just set that one, then you lower it, then you will start to count the time, right? So when the time reach, then it will stop the toasting lah. So it will stop the heating through the filaments, right? So you have filaments at the side, right? Then the filament itself is actually being controlled by this heating rate, okay. So this heating rate meaning to say the ampere or the power being supplied to the filament itself, right? So that power is actually being controlled by this heating power control switch, okay. You may turn it to the maximum, just like the iron, right? So you have your cloth iron, okay. You can control the power, right? So that to control whether the temperature should be high or low, right? So that is the heating rate of the filament, okay. So what are the parameters that we have here, okay, is we have a Q, right? So that Q is being represented by is representing the heat rate of the filament, okay. So here we assume a very simplified heat transfer model, okay, through what we call as a convection, okay, because the bread surface and the filaments are not touching, right? They are not touching, so there is no connections, okay, no conduction. So the main heating mechanisms through this heat transfer would be through the heating of the air, right? Heating of the air to the surface of the bread, as well as radiation, right? But in this simplified model, we just assume a convection model, okay, instead of using the radiation model, right? Because at one point we can also combine the radiation as a simple convection model, right? So this is a typical convection model, okay, where the heat rate, okay, with or the heat flux density, okay, with the unit watt per meter square, right, should be equals to the heat the convection coefficient, the H itself, okay, and multiply by the temperature difference. Okay, that temperature difference would be the temperature of the bread, okay, the bread surface of the bread, okay, and the ambient temperature. So assume outside temperature lah, okay, far away, okay, even though in real it may not as far as it is, okay, but here we use the simplified model, okay, we assume ambient temperature is fixed, okay, and so on, right? So what you need to do is just fill up this simple block diagram, okay, and the main difficulties, I guess, that you will face would be on this G, okay, on to get the transfer function, okay, to describe the temperature T and the heat input Q over there, right? So we have this equation, okay, given by this. So what you may need to do is just basically to derive it, okay, rederive it, okay, and I guess if you rederive it, okay, you may also get something like this, okay, equals to H T, sorry, Ts, okay, minus T, this sorry, okay, so this Ts, this sorry, Ta, okay, so T is Ta and H is a constant, okay, the Q also should be a constant lah, right? Okay, so basically if you to describe the relationship between the T and the out and the input Q, then probably you may want to write it in terms of T S over QS. Okay, so your task is just to rearrange, okay, you may use HTS minus HT, okay, then yeah, bring maybe this one over here, over there, alright, so rearrange it such that you get T over QS, alright, so as simple as that, right? So rearrange, okay, so you may end up with some items over here lah, right? Some items over here, okay. So once you get this transfer function, okay, as long as your transfer function doesn't have T, okay, you have Q is okay, okay. Therefore, when you insert your Q value into your equation, you get your relationship lah between them, right? So that is the idea of these transfer functions, okay. So you may have maybe in terms of H, in terms of TA, in terms of some Q, I don't know, right? So that would describe your transfer functions, okay. Once you have your transfer function, okay, therefore what you need to do now is to assume the H equals to 30, okay. First you rearrange this one, then only you insert this value H equals to 30 into your equations, alright, and then you have your group may have 4 person, okay, 3 to 4 persons. So yeah, each of you may contribute one value, okay. You may try with Q equals to 10, let's say, okay. So put Q equals to 10, then you have your equations over here, right? So you may have, let's say now, let's say, okay, let's say this is you get 10 Q minus TA, okay, let's say, I don't know it's true or not lah, okay. So you just insert all these things, okay, 10 over here, or maybe you have also H, right, TAH, right? So you just insert all 30 over there, then the TA here is 300 Kelvin, right? So insert it inside, see? So when you see the unit of the temperature is in terms of Kelvin, meaning to say the output, okay, that you will get here also in terms of Kelvin, the unit, that's all, right? So very straightforward, okay. So just insert it, put into your transfer functions, then you just refer to to the notes, okay, in order for you to plot the, sorry, not the time constant, in order for you to plot the time response, okay, you just use Scilab or MATLAB, whatever it is, okay, or Xcos, you just put into your block diagram, okay, insert with the equation, run, so you should be able to see the time response, okay, in terms of time. Okay, so I don't know, so maybe the curve is like this, I don't know, right? So after that, okay, from this curve, find what is the time constant, right? So this time constant, you just refer back to the control engineering methods, okay, how you can get the time constant from a graph, from a graph lah, okay, that's all. Okay, then after you get this one, then probably you may want to discuss further, okay, by but before you do discussions, okay, you may see that what is the settling time, okay, you may also realize what is the settling time, okay, TS, okay, and then maybe the final value as well, okay, what is this value, okay, whether this value will be settled or actually it will continue to grow, okay, I don't know, right? So you find what is the final value as well, okay. So once you have this one, then you think, okay, or you may search, okay, whether this final value is a proper one or not, okay, in order for you to do a toasting, okay, just use some common sense, right? Like if your final value is only now the ambient is 300 Kelvin. If let's say you get 330 Kelvin as your final value, so is it sufficient to toast a bread? Okay, you may just Google, right? Okay, you may just Google, okay, and you will realize that maybe okay, 330 Kelvin is about 50 degrees Celsius or 60 degrees Celsius. It may not able to toast your bread, meaning to say it's not sufficient, right? So you increase maybe the Q, okay, you may increase to maybe, okay, 50 or 100, okay, pick a number, right? Then you check again, okay, you find out what is the final value, what is the time constant, okay, what is the settling time, and see, okay, whether it's reasonable or not. If still not there, then you may pick the third one, okay, so you may change only the Q value, okay. So pick the third one, okay, now you compare whether the third one have improved or not, okay. So let's say you get 50, okay, you put 50, okay, then you realize the temperature too high, then you may just expect the third one maybe 40 lah, okay. So that is how you pick the three value, right? So from there you don't need to do the fourth one, the fifth one lah, right? So just say compare all these three, okay, then you just make some relationship between by increasing the Q or reducing the Q, how it will affect your time constant, how it will affect your settling time and final value, okay, and whether they are reasonable or not. That's all, right? So it will take not more than 3 hours basically, right? So you just have to rearrange this one. It may take you 15 minutes, okay, just to look into all these things, plot construct the block diagram in your Xcos or simulate, capture the picture, get all the simulations result, time constant. It may take you maybe 30 minutes, right? Okay, then capture, write your report, okay. So yeah, no more than 3 hours, right? So that's all, right? I hope you can complete this one and submit by end of Wednesday, right? So okay, that's all from me. See you, bye bye.